This is a snapshot of a computer simulation of two, relatively small, planets colliding with each other. The colors show how the rock of the impacting body, dark gray, in center of impact area, accretes to the target body, rock, light gray, while some of the rock in the impact area is molten, yellow to white, or vaporized, red. Credit, Philip J. Carter. New light shed on how Earth and Mars were created. Date: September 27, 2017. Source: University of Bristol. Summary: Analyzing a mixture of Earth samples and meteorites, scientists have shed new light on the sequence of events that led to the creation of the planets Earth and Mars. Analyzing a mixture of Earth samples and meteorites, scientists from the University of Bristol have shed new light on the sequence of events that led to the creation of the planets Earth and Mars. Planets grow by a process of accretion, a gradual accumulation of additional material, in which they collisionally combine with their neighbors. This is often a chaotic process and material gets lost as well as gained. Massive planetary bodies impacting at several kilometers per second generate substantial heat which, in turn, produces magma oceans and temporary atmospheres of vaporized rock. Before planets get to approximately the size of Mars, gravitational attraction is too weak to hold onto this inclement silicate atmosphere. Repeated loss of this vapor envelope during continued collisional growth causes the planet's composition to change substantially. Dr. Rem Cohen from the University of Bristol School of Earth Sciences, led the research which is published today in Nature. He said, "We have provided evidence that such a sequence of events occurred in the formation of the Earth and Mars, using high-precision measurements of their magnesium isotope compositions. Magnesium isotope ratios change as a result of silicate vapor loss, which preferentially contains the lighter isotopes. In this way, we estimated that more than 40% of the Earth's mass was lost during its construction. This cowboy building job, as one of my co-authors described it, was also responsible for creating the Earth's unique composition." The research was carried out in an effort to resolve a decades-long debate in Earth and planetary sciences about the origin of distinctive, volatile pore compositions of planets. Did this result from processes that acted in the mixture of gas and dust in the nebula of the earliest solar system, or is it consequence of their violent growth? Researchers analyzed samples of the Earth together with meteorites from Mars and the asteroid Vesta, using a new technique to get higher quality, more accurate and more precise measurements of magnesium isotope ratios than previously obtained. The main findings are threefold. Earth, Mars and asteroid Vesta have distinct magnesium isotope ratios from any plausible nebula starting materials. The isotropically heavy magnesium isotope compositions of planets identify substantial, 40%, mass loss following repeated episodes of vaporization during their accretion. This slipshod construction process results in other chemical changes during growth that generate the unique chemical characteristics of Earth. Dr. Hinn added, "Our work changes our views on how planets attain their physical and chemical characteristics. While it was previously known that building planets is a violent process and that the compositions of planets such as Earth are distinct, it was not clear that these features were linked. We now show that vapor loss during the high-energy collisions of planetary accretion has a profound effect on a planet's composition. This process seems common to planet building in general, not just for Earth and Mars, but for all planets in our solar system and probably beyond, but differences in the collision histories of planets will create a diversity in their compositions."